Hi guys, Mrs. Hasten here again. Um, I am going to walk you through how to run the chi-square test and then cover any last little updates on the videos. So, for a chi-square test for independence, like we've been talking about, you're going to use this with categorical bivariate data from one sample. So you took one sample or you gathered one sample from a data set and measured two categorical variables. And we're testing to see if these variables are related or, in other words, associated. And you'll also hear the words dependent or independent. So those all kind of mean generally the same thing. If you are using a TI-84 calculator or one like what we used in class, where you'll find this is in the stat test menu, chi-squared test. But I'm going to show you on Staplet today. Just so you know, this is the chi-squared formula. So basically, they take the observed value from the table, the two-way table that you made. They subtract it from what would be expected if there was no relationship at all. So if they were all proportional numbers, what would that count look like? So it's the observed minus expected. So how far are the numbers away from what they should be if there was no relationship at all? Square those just like we've done with standard deviation to make them positive. Um, Divide it by the expected. So it's not just how far away the number is, it's how far relative to what it should have been. And then you add all those up. So for every cell in your two-way table, that's how you would do that by hand. Now, you don't have to do that, but just so you have seen the formula before. And if anyone is also in AP Bio, then you might have used this during the genetics unit. All right, so your hypotheses for chi-squared test. This is different from our hypotheses for just a regular old test for proportions or means, because those used numbers and symbols. We can write this in words. So the null hypothesis is that the two variables are independent, or in other words, they're not related or not associated, because the null hypothesis means that there's no difference. The alternative hypothesis is usually the one that we're trying to test as the researcher. So the alternative hypothesis is that the two variables are dependent or related or associated. Those all mean the same thing. You're going to sub out the word variables for your actual variables. So for my example, I would say that the state that seniors live in and their favorite sport are independent. And then for the alternative, state that a senior lives in and favorite sport are dependent or related. So this two variables get subbed out for your specific variables. That's the context that this is reminding you to use. All right, the conditions. So you have the random 10% large counts, just like always. Random, you need to explain how you got random. 10% if you're sampling without replacement, which most of us are. This would be the only time you wouldn't do this is if you're running an experiment, which I don't think anyone did an experiment. I think everyone did a sample. So you just may not sample more than 10% of the population. So for example, with my sample, I had 100. Now, if I had thrown out a few of them, let's say I ended up with 98, I'd say it's reasonable to assume that there are more than 980 seniors in New York and Texas. So that would be the sentence that I would put for that. And then large counts, the expected counts are greater than 5 for each category. This ensures that you got enough data that none of the expected counts would have been 0 or less than 5. So how you calculate that is with another little nifty formula. Let's see if I can, here we go. So it's your row total times your column total divided by your table total. So let me show you an example. This is something about beef preference and geographic region. So it's kind of similar to mine. Imagine that this was sports instead. So the expected, when I normally run this as like a PowerPoint, these green numbers are animated so that they come in as we calculate each one by hand, but I don't think I can do the present and screencastify at the same time. So we already have the answers ahead of time, but to show you how I got the 90, That was from doing the row total, which was 150, times the column total, which was 300, divided by the total, which was 500. So again, it's row total times column total divided by total. And that's how you fill in for the rest. So if you want to pause the video and make sure that you know how to do this and you can calculate these for these numbers here and make sure that they match mine, that way you'll know how to do it for yours, then that might be a good idea here. The next thing you need to know how to calculate is degrees of freedom. So the degrees of freedom is your row total minus 1 times your column total minus 1. That gets a little bit, there's just a lot of math going on there. It's like, 3 different steps. And you have subtraction and multiplication going on. And I know for me, I like to have a shortcut here. So you can also just cover up a row and a column and count the number of cells remaining. So I'll show you both ways here. For that previous example, it's your rows, which there are 3 rows, minus 1, so that gives us 2, times our columns, which was 2 minus 1 gives us 1. So 2 times 1 is 2. Okay? Or, like you can see that I've marked out here, you can mark out a column, mark out a row, and count the number of cells remaining, 2. That might be an easier way to do it. You're going to do that ignoring the total columns because the totals, you don't need those for this. Okay? So that's how you do that. So when you run your chi-squared test, you're going to get your degrees of freedom, which we just went over how to calculate that, your chi-squared value, chi-squared test statistic, and your p-value. So let me run over to Staplet. If you watched my previous video, you know that I just kind of made up these numbers here for our purposes so I could get, a two-way table that you could see and a fake graph here. Now, I'm going to make a prediction here. Looking at how different these graphs are, I'm going to say that there is a relationship between where you are and what sport your preference is. I think that these are different enough that if you're in Texas, you're more likely to like some sports versus in New York, you're more likely to like different sports. That's just my own prediction. I actually have not run this test yet, so I might be miserably wrong here. But you can kind of get an idea based on the look of this graph here. So make your own prediction before you run your test and see how you did. So down here under perform inference, chi-squared test for independence is what we're running. Perform the inference. Now I got a warning here, at least one expected count is less than 5. That's because I made up these numbers and I made up just really small numbers, but remember that I took a sample of 100 actually, so these numbers should have been a lot higher. So hopefully I wouldn't have run into that problem. If you do run into that problem where your expected counts are less than 5, if any of them are less than 5, then you need to go back out and gather more data. This gives me the chi-squared, p-value, and degrees of freedom, which I showed you how to do degrees of freedom by hand, but this Staplet will also just tell you what it is. And I was a little wrong. 12% or 0.12. That is not less than alpha, so we are not going to reject the null. So I guess these are not as different as I thought they were. Okay. So speaking of your conclusion, let's run back to the PowerPoint here. Slides presentation. The conclusion is the same conclusion that we've been doing. So if the p-value is low, reject the hoe. That's what I do in my class. But if you want to be more statisticky, if the p-value is less than alpha, reject the null hypothesis. That means that there is convincing evidence of the alternative. And the alternative, remember, was that there is a relationship between your variables. You're going to sub out variables again for your actual variables. And if the p-value is greater than alpha, then you're going to fail to reject the null hypothesis. Then that means that there is not convincing evidence that there is a relationship between the variables. All right. Okay, I wanted to also head over to Canvas. So hopefully you got this video link here. This is still in progress as I'm making it. So when it says will insert link, you probably won't see that because the link would have been there. So you're going to get your degrees of freedom, chi-squared, and p-value from your data. Use your p-value to form a conclusion. That conclusion should answer the question from week 1. And now you're going to make a video. Now, hopefully you have already started your video and now you just need to add on the rest of it. But in case you haven't started your video yet, I have put the links here again of some possible apps you could use. Now, if you have another video editing app that you like to use, feel free, as long as you can get a link at the end of it, a link that you can share with your teacher, and your teacher does not need to have a login to view that, except for like Frisco ISD if it's from your Google Drive. But most of these you can upload to YouTube, or you can just get a shareable link for those videos. Let me show you how to get a shareable link, because I know that some of my students have struggled with that. I'm going to go over to, you're just seeing all behind the scenes here. Let's go to my folder that I have one of the videos that you've already watched. Okay, let's say that I want to put the chi-squared project intro video somewhere. When I click on that, again, hopefully you already watched this. We do not need to see that again. Many of my students, and maybe you too, are copying this link from your address bar, and that is not how you get a shareable link. Instead, you want to go to the 3 dots at the side, or if you're in another application, it might just say share. If you're in Docs, if you're in Sheets, anything, it might just say share there. But you want to look up here and share. Do not type my name in here. Do not type your teacher's name in here. We don't need editing rights, and this just clogs up email. Instead, you want to get a shareable link. Now, I've already done this for this video, so that's why it shows up here, but you want to get a shareable link. When you click that, then you will have this. Now, I also had to go to advanced options to make sure that it was anyone with the link could view. This was what that page looked like when I clicked that initially. So I have it as anyone with the link can view. If you feel more comfortable leaving it Frisco ISD, that's fine. Your teachers all have Frisco ISD logins and we are logged in with that, so you can leave that. But you do not need to specifically share it unless your teacher has given you that directive. But I think most of us would prefer to just have a link there. Okay, back to Canvas. And again, you're going to turn in your work to the assignment on Canvas. I think that's it for this week. Again, if you have any questions, email your teacher, and we cannot wait to see your videos. They're going to be awesome.